So I just want to talk about the gradient and the different ways that you can find the gradient. Okay, so method 1. If you're looking at a graph and you've got the graph drawn there, so that's 5 and 4, then the gradient can be found by just looking at the rise over the run. And seeing that this is actually a negative because it's going down, negative gradients will go down and positive gradients will go up. Okay, so that one's a negative, that one's positive. You can make an n out of it. That's how you can remember that it's negative as well. So the gradient here would be 4 over 5 and it's negative, so it's minus 4/5. Whereas another example, if it was going the other way, so that's 3 and minus 4, the gradient there would be 3 over 4 and it's actually positive. We don't care that this here is a negative 4 because the negative 4 is only there just to, it's just like an intercept. The actual ratio of the 4 over 3 runs all the way up and down that line. The negatives are irrelevant. You're after like the length or the distance. Okay, so secondly, if you're given 2 points, you can always find the gradient because you just use the 2-point formula. y2 minus y1 on x2 minus x1, which really just models the rise over the run. Because if you have 2 points, this is the difference between the y's is here and the difference between the x's is here. And if you did the rise on the run here, so the rise on the run, then that's what you'll get. You get this formula here. So for an example, if you're given 2 points and you're asked to find the gradient, so you want to be able to find the gradient between A and B. Let's put A is minus 4, 3 and B is 2 minus 1. Then the gradient would be, now this is x1, y1, x2, y2. Now it doesn't matter which point you label what, because the gradient between A and B is the same as the gradient between B and A, because the way it is sloping is exactly the same. So if you start with the y, you go y2, which is minus 1, minus y1, which is 3, over, and then we do the next part, 2, which is x2, minus x1, which is minus 4. So that's going to be minus 4. Minus 1 minus 3 is minus 4. 2 plus 4 is 6. So it's now going to be minus 2 on 3 as your gradient. That's your example. Okay, so we've got it from a curve. We've got it given 2 points. And now we're just going to look at, I want you to look at if you are given the angle. So if you're given the angle that the line makes, and they usually say with the positive direction, with the x-axis. Now what they actually mean by that, like say your line's like that, the angle it makes in the positive direction with the x-axis is that one there. So the positive direction is like the anti-clockwise direction. And we've got 2 types that we're looking at here. One where it's sloping that way and one where it is sloping this way. The angle we want always starts here on the x-axis and goes in the positive direction. So how do you find that gradient there? You might notice that this is the rise and this is the run. And if you drew your own little triangle on this one too, that would be the rise and that would be the run. Difference is one of these has an obtuse angle and one of these has an acute angle. The other thing to notice is that this one here has a negative gradient. So the negative gradient appears to be with the obtuse. And this one here has a positive gradient. So the positive gradient is with the acute angle. Okay, so if you are given the gradient, you can find what that angle is. So if you're given the gradient, find the angle theta that the line makes with the positive direction of the x-axis. With the x-axis, we'll just say in the positive direction. Okay. So first of all, given the gradient, all right? So the gradient is equal to 2. The gradient is equal to minus 1. Okay. So if the gradient is equal to 2, that means that the actual rule for finding the gradient equals tan theta. Okay. Now, if it is an obtuse angle, then the gradient is negative, and if it's an acute angle, the gradient is positive. So if you have a negative gradient, then you still go tan the minus 1 of m, okay, and you make it positive n. Then what you do is you go 180 minus the tan, that minus whatever that answer is. And that will give you what theta is, okay? But if you have a negative gradient, a positive gradient, then you do the same thing. Just go tan the minus 1 of m, and that will give you your angle. So when I'm looking at this one here, if I want to find the gradient, that means that tan theta equals 2, and theta is tan the minus 1 of 2. And you just have to put that into your calculator, go shift tan of 2, and you'll get your angle. It will be an acute angle. As opposed to this one, I'll find it in a minute, I'll just get a calculator. So if you went tan the minus 1 of 1, you end up with 45 degrees. But we don't want the little angle inside here. We don't want that angle. We want that angle there, the one that makes it in the direction of the positive axis. So theta is 180 minus 45, so you end up with 135 degrees. Okay, so when you go shift tan on 2, you end up with 63 degrees, and it's an acute angle because it is a positive gradient.